Hey guys, AxiomaticUncertainty here, and I'm once again just going to be doing a random medium problem from binary search. Hopefully I won't have seen these. I've only done 1/10 of the medium problems on this website, and so we'll see how it goes, and hopefully be able to take something out of this. I'm just going to try to give like my thoughts as I go through this problem and sort of give advice. Yeah, so let's see what we're doing here. Palindrome linked list. Um, okay. Yeah, so I think there are a few aspects of this problem that are interesting. Um, so for starters, I think here um, we naturally could do this one way. So I'll do that way first, and then I guess I'll cover the other strategy that I think might work. So the first strategy would be uh, get list length, right? We get the list length by just traversing it until the end. Then what we do is we um, as we're doing this, and add nodes to stack. As we're doing this, we're going to add all of the nodes we're finding to a stack. Once we get to the end of the list, we're going to traverse the list and check top of stack each time. Pop after checking. If both halves are correct or are same, the list is a palindrome. So I think this is the most natural, naive solution to this problem. Obviously, this is pretty simple. You still get the O of n time. Obviously, here you have to do 2 traversals, um, but optimal time. The only problem here is that we get inoptimal space. We end up with O of 1 space. Um, However, if we're not allowed to mutate this linked list, this is the most efficient way, I would say, of doing this. So I guess we'll just write that and demonstrate that sort of idea. So we'll say stack LL node s equals new stack, and obviously if you're writing this kind of problem during an interview, you want to use more descriptive variable names, or at least clarify to your interviewer that typically you would. Often during interviews, I will say like, oh, I'm using this sort of abbreviated name because it's faster, um, instead of sort of uh, forcing myself to use annoyingly long names and trying to think of something that's descriptive like I would at an internship or like on an actual code base in general. Um, I'll just come up with a short and sweet abbreviation that I can use where I can understand it, and then I'll just clarify to the interviewer, if I had more time, I would be writing these variable names differently. Mileage may vary on that, but that's what I do at least. Anyways, so what we're going to do is we're going to go and we're going to create a node that's going to be a pointer to our starting node, and we're going to traverse the list, and we're going to have a length, and what we're going to do is we're going to say while traverse is not equal to null plus plus L, which is going to increment our length variable, and then we're going to say traverse equals traverse.next, and we're going to traverse through the list. Now at the end here, we're going to have a variable indicating the total length of the list. If the list length is odd, we only want to traverse, we know the middle node is going to be the same as itself, so we only want to traverse the first half minus 1. Otherwise, we want to traverse half, and if it's even, we should traverse half regardless. So my approach here is going to be, we're going to say int I equals 0, and then we'll say we can just use a for loop for this. We'll say for int I equals 0, I is less than, I is less than L over 2 plus plus I, and we'll say traverse equals node again. We don't really need to instantiate a new pointer. We can just reuse the one we created already. And we'll go through and we'll say traverse equals traverse dot next. We'll say if, or yeah, we'll say if s dot pop is not equal to, or yeah, s dot pop, actually we want the value, so we'll say dot val is not equal to traverse dot val, then we want to return false because it's not a palindrome. And otherwise, at the end, we know that it's a palindrome, so we want to return true. And I think that this should work. So you can see here, we got our stack for step 1, where we get the list length and perform this addition into this. You can see that's here. We're just going through, we're getting the length. We're also performing this traversal. And then here you can see we reset to the start. We go in a for loop through the first half, right? You can see that here. And we pop each time. In this case, we're popping and checking at the same time, but you could technically do a peek operation here and then check it and then pop afterwards if you want to be maybe a little bit more explicit and make this easier to understand. And then we're going to return false here. Otherwise, we want to traverse to the next node and we want to return true at the end because we never returned false, meaning we never found a set of 2 nodes that were not equal. You can see if we run this, let's see what happens. Looks like I am getting an empty stack exception. Let's see what the issue is here. Oh, yeah, my bad. I forgot to actually push the traversal node onto the stack each time. And hopefully that fixes that issue, though I am not 100% on that. Okay, yeah, it does, it looks like. We'll see. Yeah, so you can see this works. And this is an optimal solution if we can't mutate this list. So during an interview, the first thing I would ask probably would be, can I mutate this or can I not? If I can, this is what I'm going with. Or if I can't, this is what I'm going with. However, if they tell me, you can mutate the list, so, try to optimize with that in mind. Now I'm thinking, is there a constant time solution that I can devise that's going to sort of solve this problem for me? And there is. There is a constant time solution that I can think of right now. And that solution involves finding the midpoint using the fast and slow pointer approach, and then reversing the sublist that begins with its head at the halfway point. So if that makes sense, basically what we're performing here is we're performing like reversal of a linked list, but just we're ignoring the fact that there are previous elements before the head. So let me think here for a second about what I want to do. We'll come up with sort of an approach. So I think what we'll do is we'll do what we were doing before this, except we'll have obviously our fast and our slow pointer. So we'll have slow equals node, fast equals node. Now, let's think for a second. Obviously we want to do like while fast is not equal to null and fast.next is not equal to null. We want to perform this sort of operation here. So what we need to do is we need to think through a couple of cases probably, because I don't use this approach often enough to do this just off the top of my head. We need to think through a couple of cases and figure out which one is going to give us the halfway point that we want. And by that I mean I think here we want either the midpoint if the array, or if the list has like an even number of elements, or I think we might want the I think we might want the actual second or the next element after where the midpoint would be if they're an even number of elements. So say there are 6 elements, we might want the 4th node instead of the 3rd, indexing from 1, of course. Let me think about how we want to approach this. I think that's probably going to be our best solution. Okay, so let's see. Here we have obviously this iteration we're performing. Let's say this a list is length 1. We start there and we stop immediately because the fast and slow pointers can't move. In that case, we have the midpoint as the return value. If it has a length of 2, so like this part here, we don't move forward. Or actually, fast is not equal to null and fast.next is not equal to null. So we move forward the slow pointer by 1, and that returns the second element back. And then for the third case, where we have length of 3, we move the fast pointer to the end here, and the slow pointer to the middle here, and then we return because the condition's no longer met for the next loop. Say it's a length of 4, same kind of thing, right? We're going to go to here, and we're going to bring the slow pointer here, but then here we'll have another node here. So we'll actually move the fast pointer to the null node at the end, and we'll return this node. So this seems to work. I can't obviously really say like for sure that I think that this works, but my intuition tells me it does, and when in doubt, I would say just go through a few test cases like I did there. Just in your head, sort of think through, and in an interview, it's actually really useful. Just go through, explicitly with the interviewer, this is my thought process, this is how this would work, this is how I'm going to solve this part, work through these problems aloud, because it really shows your thought process, and it also proves to them, I think, that you're not just, memorizing stuff. So yeah, this is what I think needs to be done in order to retrieve either the middle element, or if there are an even number of elements, the element after the middle element. So now that we have that, I think what we want to do is we want to just reverse the rest of the list. I think the way in which I've seen this done, because I've done that sub-problem before, would be to create a previous node that's going to be null, and a current node, which is going to be, in this case, our slow pointer. What we'll then say is while cur is not equal to null, right? So while we're at an actual node, we want to set previous, we want to say, actually we want to get, a temporary node that's going to be equal to the next node after the current one. Then we want to set the current node's next node to be equal to the previous node. And then we want to set the current node to be equal to the temporary node. And we want to just continue this until we get to the end, at which point we reverse this list. Now, thoughts on what we want to do now. I think what we can do is we can again just keep track of the length of the list, perhaps. Right, so we'll move in lengths of 2. And obviously if the list has a length that is even, let's see, if the length of the list is, I just want to be sure we have a good system for determining how long this list really is. We obviously have the movement of the slow pointer, but that can overestimate halfway, and we want to make sure that we're not overshooting. I think the optimal strategy here might be to iterate forward until the end of the list is null. So yeah, I think that's what we're going to do. So at this point here, cur is right side of list, node is left side of list. those are the two sides of our linked list. So here, this 5 would be the right side, the current node. This side would be the left side, the node. And what we'll say is while cur is not equal to null, cur equals cur dot next, node equals node dot next, return true at the end if we never had a false evaluation. And here we want to check if cur.val is not equal to node.val. And if that's true, we want to return false, right? So if there's ever a value that's not equal there, we want to return false. And I am not sure if this will work, but we can try running it. Okay, that's accepted. So maybe we want to just submit and see what happens, and then I can explain. Cannot read field next because value is null. Where is this happening? Test case node equals null. Expected true. Okay. Oh, okay. Yeah. We're getting an error here because we're making the assumption that there's at least one node here, I think. Though that's perplexing to me. Line 12, while fast is not equal to null, and oh, why did I only write one ampersand there? Okay, now we're just getting an actual error, which is, I guess, good. Let's see what's going on here. I think the best way of fixing our issue here would be to actually test this. So the test case is 1, 0. I hate how stubborn this thing is about letting you copy test cases. And let's try outputting our current node and our node, and we'll output both of these values. Obviously, during most of these videos on YouTube, nobody ends up actually debugging their code like this, but I think that there is no point in just sort of sitting on my hands and saying, like, here's the issue. And saying, like, I am unwilling to sort of show that I can make mistakes with these things. Yeah, so I think this is the only problem here. I was saying that the current node should be the end of the list, but actually the previous node should be, because in the last case here, right, current will be null. That's the exit condition for that loop. Now we're getting an error, but I think this is probably a separate issue, and I of course deleted my print statement, so I can't see why. Are we actually getting any outputs from this loop? No, we are not. Oh, well, I forgot to update the previous node. Okay, yeah. That is interesting. I totally blanked on reversing this linked list, and I forgot to update this previous element. But yeah, you can see the solution works also. So if you're allowed to mutate, obviously you can now achieve this better performance of O of n time and O of 1, right, constant space. So yeah, I guess I can go through and maybe annotate this a little. So initializing our fast and slow pointers. And then here what we're doing is we're going until we can't set fast.next.next. Yeah, we're iterating forward here. At this point, Uh, we have slow equals linked list is what we'll call LL. LL dot length over 2, but instead we want to take the ceiling of this. So that's like mathematically what this should be, right? We're getting the um, halfway point in the length of the list, right? And uh, otherwise, we're getting this. I think that's probably the fairest way of putting that. Maybe subtract 1 from this, but yeah, I think this is what it is, maybe. Then here we have um, reverse linked list, right? And this is pretty basic stuff, I think, in terms of the actual logistics. And this is such a well-known problem, I'm not really going to go over how this is working. But we're kind of combining these two steps, right? I think this is kind of important for people who haven't done a lot of these interviews or don't really have a good handle on this to understand, your interviewer isn't expecting you to necessarily be able to come up with, for example, the fast and slow pointer approach during the interview. But what they are expecting you to do is to recognize patterns, um, and more importantly, be able to take your recognition to the next level and say, like, um, here are 2 patterns uh, that, a part cannot be used to solve a wide variety of problems, but together can be used to solve um, lots of problems, um, in a lot of different ways. So like here you can see, you know, we have 2 sort of distinct approaches that, wouldn't typically be considered. These aren't like related in any particular way other than that they're typically used on linked lists. Um, but you can see here what we're doing is we're making the observation first. Okay, um, well, we can determine, you know, uh, whether or not this is a palindrome if we can traverse forward and backward at the same time. Well, how can we traverse forward and backward through this list at the same time? Well, I guess we can reverse the back half of the list. And so then you're saying, okay, let me find a midpoint or somewhere I want to start the reversal at, and then let me perform that reversal, like I'm doing here. And then afterwards, it's just a matter of figuring out what your exit condition is, performing the checks, and, voila, you got your solution. I don't know, this was kind of, rambling a little bit, but I'm just sort of thinking aloud, trying to give some input and give an idea of how to solve these kinds of problems. I know I've seen people complain, how am I supposed to do this without having a good understanding of, proofs, or like how is this expected of me? How can I possibly solve this during an interview? So I'm trying to sort of shed light on that by just sort of going through problems, that I haven't seen, and just, I don't know, trying to give my thoughts on them as I go through them and sort of work my way through these problems like organically. Which, as I mentioned, is something I don't usually see. A lot of people sort of plan these out really well, and I think because it becomes scripted, it's a little bit harder to understand how this person is coming to these conclusions. And maybe I jumped a little bit too fast. I don't know. I've done a fair amount of these problems, so it's kind of harder for me to um, need to spend, a long time sitting and sort of thinking, because I've kind of done enough that I recognize a lot of these patterns. But yeah, let me know if you want me to change up how I'm doing these, but otherwise I think maybe at some point I'll just upload another one of these and just keep doing them because they're kind of simple and fun and they're whatever.